Hey guys, Lucas here and welcome to Coding with K. This is what we've worked on in the last video, an n-body gravity simulation, which has no gravity yet, only a bunch of spheres that move up and down, which is actually very hard to see right here, so let me reduce the number of spheres from 500 to, let's say, 10. I tweaked the program a little to showcase this. Okay, here you can see it. Each sphere just moves up and down, and the more you add, the more it looks like a wave. That's pretty cool. That is of course the power of the sinus function. But anyways, this has nothing to do with the gravity yet, so we will have to start fresh pretty much. It was just an exercise to get the graphics going. Now, speaking of graphics, I found out that there is a better way to update our screen. I use screen lock and screen unlock to prevent the screen from flickering when changing the content. Now, the better way to do this is actually to make use of a particular argument of the screenRes function, which is number of pages. So in essence, you can set the number of pages to 2 like so, and now flip between the 2 pages. I edit one, and then once I'm finished with the edit, I flip it to the page that is displayed. But first I have to set which page is displayed and which page is in the background. So I think this should be right way around. Let me check. Okay, the work page is the first and the visual page is the second. So we work on page 1 and we display page 0, and now under update graphics we simply flip the page like so. I believe we flip the invisible working page to the displayed one. Let me try it. Yes. And just for test purposes, let's do it the other way around. This should be just black. Yes. Okay. So we essentially done the same, but without locking the screen and therefore freezing our inputs, which is pretty cool. At least for me, the application now runs a little bit more responsive. Now, before I delete everything and start from scratch, I want to still explain what we've done last time and what my tweaks were. Okay, so in red what you see are just comments. These do nothing but to explain the code. Up here I add the title and the author, which is me, but these are just variables I defined, so you don't have to do that. I just want to display the name of the application and my name on top. Where is it? Here. I draw a string to this position. And that is of course this what you see up here. Now, same with the window size, you don't have to define variables for this. You can simply plug in the numbers right here, but I of course want to use the window width a couple more times, so I define the variables. I also find this is more clean. This here are my time values, which I use to increment the time as the loop iterates. That's the main while loop here, of course. Wait, let me add a comment. Main program loop. This repeats until I press escape, which is the character 27. And what the character 27 is, I can check in the ASCII chart here. It is escape. I also define a variable pressed to the key pressed in key, so that I can use this value over here to check which keys are pressed, because I want to actually change the wave, pressing plus and minus. Let me try it again. I now press plus and the frequency increases, although this is not strictly speaking the frequency. If you count the number of waves which disappear to the left, it always stays the same. So 1, 2, 3, 4. 4 seconds for a wave to disappear. Now let me increase the wave, and now 1, 2, 3, 4. It takes the same amount of time. So it's not the frequency changing, but the scaling on the x-axis. Alright, let me add a couple more bodies again. Where is it? There. Here again. You can count it if you want, but I hope you believe me. And this is of course done using this k value I declare over here, and I change k using my buttons. And k multiplies this part here in the sinus function, which is not part of the main wave. It is just added. And this addition is done to every sphere's epsilon value. But wait, I think I didn't explain what an array is in the last video, so let me quickly create a new test file. Okay, so in here I can explain what an array is because it's way too messy in the other file. So dim integer equals 0 like so. I can print x. Okay, let me change this to a console application. Now, I've declared a variable x equals 0 and simply print it. Okay, not that spectacular. And in the last video I created multiple values for x, for each sphere its own. This of course works, but it is very tedious. If you consider I use 500 spheres. So a better way to do this is to use arrays. An array is simply the same but stores multiple values. So I have an array x, which I define using these parentheses, and now simply put in the number of values I want. In this case I want 100 x values. And now in order to set them, I could either use squirrely braces and plug in the numbers like so, but that would be of course also a lot of work. Or I can simply use a loop. For I is integer equals, equals 0 to 100. And next ends the for loop. And in here I can say x of I equals, let's say I. And this print I can also put in here to print it out. X of I. Okay, I think this should work. Bam. Now of course that was a little fast, so I add a little sleep as well. Sleep for 100 milliseconds. Okay, this is our array being filled by values now. And there we go, 100. And that's the same I've done for every single sphere. I used x and epsilon coordinates and 500 of them. And of course the value bots or bodies stands for the number of spheres. Okay, should I explain anything more? I think I've done the same to the colors because I wanted each sphere to have its own color. So I created a color gradient. And this gradient simply runs from, so it runs from red to blue, I think. No, from blue to red. So the color blue is 0.0.255 and the color red is 255.00. So what I have to do, I have to start at 0 in red and go to 255. How do I do that? Well, the number of bodies is of course 500 and I start at 0. So 0 divided by 500 is of course 0. Now the last value will be bodies minus 1. That's because of course our array starts at 0 and ends at 99 or at 499. That's 500 values. So at 499 we end at 499 divided by 500. Well, you know what? I can actually add the one here. I only need the 499 here, but in here I actually want it to divide 500 by 500. so that I get 1 times 255, right? And that is of course 255. And here I want the opposite, so I subtract this value from 255. So I begin with 255 minus 0 and end with 255 minus 255, which is then in total 0. I hope that makes sense. Now I do the same in here, plus 1. Okay, it didn't change much, but the last red value is a little bit more red than before. Okay, I hope that is clear now, so that we can move on to the more complicated stuff. Let me just save this under a new name. Okay, so what can we delete? I think we can delete these two lines. This we will need, this too. Pressed key. Update the physics. We need T. Draw string stays the same. Okay. I will keep this for now because you never know what buttons I want to press. And I think that should be it. Yes. Okay. Well, now back to the test file because I have to explain another new concept. And that is custom types. So we define a variable like so, and the integer here is its type. It's a whole number from -infinity to +infinity. So -2, -1, 0, 1, 2, and so on. Okay, integer is the type. And I can of course also create my own types, which I will need for my n-body simulation, mostly to make it more tidy. And as an example, I create the type position. And type, and this position has two values, dim as integer, x and epsilon. Doesn't look like much, but now I have a new type where x and y coordinates belong to one position. And to declare a new variable with a new type, I simply use dim as position and just call it myPos. And that equals, for example, I think it's parentheses actually. Not quite sure anymore, I have to try it. My position, oh wait, it's .x now. This is how we access the data inside position. And my pos.epsilon. Let me try this one again. Yep, it works. 0.1. For testing, let's try another value. Maybe it was just luck. No. That's how we can define a new variable of our type. And I will make heavy use of this in our gravity simulation. But I won't use position. Instead, I will simply use n-body. I will define an n-body, and that n-body of course has a position x, and position epsilon. But that's not all. It also has a speed, and I just noticed it's not an integer. The position is actually a double value because I want it much more precise. Same with the speed. Speed also has two values, speed x and speed epsilon. Now this might be confusing. Why has our speed two values? That's simply because our coordinate system is 2D and we somehow have to represent speed that is diagonal, not just vertical or horizontal. This will become more apparent as we go on. The position is hopefully clear. So is there anything more we have to add to our n-body? Let me think a little bit. I think, well, we could add mass as well. Dim as double mass, why not? I think this should be it. I can now copy and paste this to our main file. And I do it above the declare variables types like so. And I can create a new body. Before I do that, I will again define a variable to store the number of bodies. Let's start with 2. And now before we create our screen, we have to actually define new variables of our new type. And since we are going to use more than 2 in the long run, I will use a for loop. Like so. Oh wait, before I fill our n bodies with information, I actually have to create them over here. Numbodies. Like so. Yeah, we did the same in here. And now I can fill my n bodies with information. N bodies I dot pass x is something. Same with 5 more times. No, 4 more times. Epsilon, speed x, speed epsilon, and of course mass. And for mass, I will just use 1 for now for testing. And for the position, I actually want to spread them randomly across the screen. And as we've learned in the last video, that is simply the command rnd, which creates a random value between 0 and 1, a random double value. So if I want to randomly spread it across the screen, I have to multiply this random value times our screen width. Same to position epsilon, only with the height. And for speed, I will simply keep it a random value between 0 and 1 for now. I will probably change that. But again, we're just testing now. Okay, so I have now created 10 bodies, which I will spread across the screen, but of course have to print them. And this will be done in our update graphics section of the main loop. We basically have to iterate over all of them again. So I'll just copy and paste. And now comes our circle function again. And I already regret that I have deleted the others. Could probably use some copy and paste now. But anyways, wait, for clarity I will define 2 more values, x and epsilon, just as a placeholder, so it's more clean. Because now I have to actually access the n bodies position x, like so. And of course, don't forget the parentheses. Okay, and here is the position of the circle inside the loop. Now if I could also add this one in here, but that gets messy real fast. I think this is better. Now of course I also need a color. Wait, I could in theory also add a color value to my n body. Dim as u long, I think it was. Color. Or just col. Because color is actually some kind of keyword. Now, why u long again? That stands for unsigned long. So a value that is not negative, but consists of whole numbers. And that of course stands for our RGB code. At least when we go to RGB, I think, CU long. There they do it in this example. I think this is where I got it from. U long color, like so. And we are simply doing the same. Okay, so our end bodies now have a color option as well, which I have to initialize in here. RGB, and I will simply use random colors times. Okay. And you know what? While I'm at it, I'll also add a size. And that size will be the same for every sphere for now. Let's say 10 pixels. And here oh wait, I think it's the other way around. But again, let me check that. So step X epsilon, radius, then color. Radius or size and then color. Okay. Now we have a for loop which iterates over our bodies. And we create circles for each one of them. I think this should work. Oh wait, let me fill the circles again. Wait, was it 4? 1, 2, 3, 4 commas. Yes. Okay, I think this should work now. Let me try it. Oh wait, put that to GUI again. We have an error in line 18. No wait, in line 25. Element not defined. Oh wait, it's speed epsilon, not speed. Like so. I think this is now right. Cool. We created 10 random spheres on the screen. Now, they are random, but you may notice something. If I keep rerunning the program, it actually always stays the same. What kind of random is that, right? And that is of course because computers don't know what random is. They have to calculate everything. And if we start a program with the same initial conditions, it will always produce the same random numbers. So what we have to do is to initialize the program with a random seed. And for that we have a keyword called randomize. If you look in here, randomize takes a seed and an algorithm, but we are only interested in the seed. And the seed can be any random number, like so. I think I need a comma actually. Wait a second. No. Now if I start, we start with a new random pattern. However, since our seed stays the same, this pattern will never change again. So in essence, if we don't randomize, I believe it always starts at 0. Yes, that looks like the pattern from before. Maybe you can reverse the video to check it, but I believe I saw those two before. So by default it starts at 0. And now we need some kind of randomized seed that changes every time the program runs. And there is only one solution to that. And that is using the time. Checking this keyword. Oh wait, in here we can't really see what it returns. So you know what? Let's check it in our test function. I will simply print the time. And the time is 17:55:04. Now that is not a good seed yet. What we actually need is to transform this time into an integer, and that is done by cast to int. You can again check the definition in here. Converts a numeric or string expression to an integer. And now 17. What is going on? Maybe. That is awkward. Why doesn't it work? it should work. But it seems to only pick up the first number, and that is 17. Why is that? Okay guys, so I found a solution, but I honestly don't understand it. In the example, they use randomize, 1. And they explain, seed the RNG to the method using C's rand. But using the comma, they would actually not seed it, but choose an algorithm. So they choose the algorithm 1. And that algorithm seems to do some magic so that it generates new random numbers. I suspect they use the time internally. However, all we actually have to do is to add a comma. And that comma apparently changes the default algorithm to something. Not quite sure to what. But if I just add the comma here, I receive completely random values. Now this might actually be a bug, I'm not quite sure. So I will definitely post that or ask someone about it. But anyways, let's just accept it for this video. Okay, so I have now randomized my random output for this function here. Oops. Okay, I create 10 random circles on screen, but there is no physics of course yet. And the first kind of physics I want to add is to use the speed each has to move them across the screen. And that won't be done in graphics, but under update physics. So I will use another loop to iterate through my n bodies. N bodies I. Now comes the interesting part. We have to change the position of our n bodies using their speed. And that is quite simply done by adding the speed to the position. Kind of a hack, to be honest. So the speed is nothing but the number of pixels we want our position to change per loop. Kind of makes sense, I think. Although for consistency we actually add to add our dt in here as well, which for simplicity I will leave out. So if you want to be super correct, you have to multiply speed by dt, because the position in pixels is not a speed, and speed always contains time. And in order to cancel it out, you have to multiply it by dt. What this leads to is a consistent speed no matter how quickly the loop runs. So if I don't do that, of course the n bodies will move faster the faster the loop runs. But I don't care for now. It should still work. Okay, let's check again. This of course is not an x, this should be an epsilon. And is that it? I think so. The position now changes per loop by the speed. And like so. You know what we could do? Now you don't have to do that, but right now our x and epsilon values are integers, while our position is a double. It's declared up here. Now this still works because it automatically turns the double into an int, but to make this more clear to the reader, I will add a cast to int in here, so that it is clear that x and epsilon are actually int values. And they are of course int values because our screen pixels are integers, not doubles, or not floating point values. Okay, so now the position should change per loop and we should observe the circles move. Let's just give it a try. Bam. But that doesn't seem quite random, to be honest. They all move to the right, to the lower right. And that is because, yes, because our speed we currently add is always positive from 0 to window X. Oh wait, in here. From 0 to 1 it is actually. And in order to move left, the speed had to actually be negative. So what we have to do instead is to subtract it like so, I think. Wait. No. Negative 0.5 plus a random value of 0 to 1 is a value between negative 0.5 and plus 0.5. I think this is correct. But I actually want the value between negative 1 and 1, so I'll do 1 instead, 1.0, and multiply the random by 2. Now this part goes from 0 to 2 and is added to negative 1. So we should get a value from negative 1 to 1, I believe. Yeah, I think that's correct. Let's try it again. Boom, it works. We created the next step of our simulation, and that is we create a number of n bodies and they move around based on the speed they have. The next step is to change the speed based on gravitational forces. But since that is mathematically a little bit more complicated, I want to make it a separate video. I hope you don't mind. Now for special effect, I want to reduce the size and create more bodies. Where is it? Number of bodies. There you are. Let's create 100. Boom. But that's not 4. Where's the size? Here is the size. Like so. Much better. Okay guys, this shall conclude the video. Auf Wiedersehen and thank you for watching.